Hey, in this video I want to talk about code libraries. Specifically, I'll be talking about writing libraries in C++ and how those are distributed. You may know some of this stuff already. I just wanted to make something where it's all in one place, comprehensive. So when I talk about code libraries, I'm talking about ways to share code that you've written with other people, or ways to use the code that other people have written in your own programs. So maybe the easiest way to do that is just like copy and paste, right? You just send them a file. But that has problems because you can't easily update that code without messing around with your code. It has some very strict limitations because you're just hard coding their code into yours. Also, licensing could be an issue depending on who owns that code and whether or not you're really allowed to use it in your own code or in a product that you're creating. So there are several mechanisms we can use for actually sharing code and using code that other people have written. So one of those mechanisms is built into your compiler, standard library code that is distributed with Visual Studio or whatever compiler suite you're using. So just as an example, one of those is the CMath library. C++ doesn't actually have its own math library, so it inherits the one from the C language. CMath, this is the same in C if you wrote math.h, but the C++ header is CMath. And this gives you access to all sorts of functions like pow for getting the exponent, exponentiating some value. So there's pow and powf to give you a float return. Most of these math functions, they return doubles. So you can do like some number squared, right? Or you can do some number square rooted if you want to do a fractional exponent. You can also do calculations using like sine and cosine. Sine of whatever, 2 times, let's do mpi. So mpi is the built-in pi constant, but it is not defined by default anymore. It used to be. You have to supply a special preprocessor definition in front. Now I actually forget what that is, so what is it? I'll look for it. CMath mpi. Okay, use math defines. There it is. Okay, so if you define that preprocessor symbol, you don't have to define it to anything, it just has to exist, then it should make mpi available to your program. So the problem here is that something is already including CMath for some reason before it gets to this line. So let me move my IOStream include down. That is weird. Probably shouldn't happen that way. But if you get that error, you can put your CMath header earlier. And make sure you use math defines in front of it. Could probably do that in front of IOStream instead. Alright, there we go. There, it works. So, you can do all sorts of things. You should take a look at what functions are available in the CMath header. And this is one kind of code library, one that's built in. You include the header, it's automatically linked for you, and you can use the code immediately, start calling functions in that library. So another kind of library that's very similar is what's called a header-only library. So while technically you're just including the header here, you do have to link to the code that's in the math library. But there are libraries that can be constructed using just a header. So if you've written a template class, then you kind of have that idea, because those are generally done entirely within a header. Alright, so one of those libraries is from a guy, Sean T. Barrett, and his website, nothings.org, and he goes by STB on a lot of his stuff. So there's some cool things here you can check out, but I'm interested in his code on GitHub, where he has a whole bunch of these header-only libraries. It's pretty nice. He's got a bunch of cool things here. So if you scroll down to this table, it gives you a little description of some of these. There's sound and image loading, some cross-platform string manipulation, Perlin noise, all sorts of things. There's even like a include parser for strings, which is kind of cool. The one that I like, I actually use a lot, is STB image, and so you can use this header to load a lot of common file formats. It's kind of a big, messy header. Well, it's big. Messy is, I guess, relative and subjective, but it's big. 8,000 lines, and what you do with this is you include the header just as normal, but then you also include the header with a special define in front of it in one of your source files, and that kind of acts like it's part of your program, but it's really easy to swap out this header if it ever gets updated. You just swap out the header, recompile your program, and you've got the updated version. So that's pretty convenient, and some people really like that approach to making libraries. But there are still some drawbacks. So there's another type that's extremely common, one that I use all the time, called dynamic link library. So dynamic link libraries, they link at runtime. It's either at launch time or during the runtime of a program. If you just link normally to a DLL, this dynamic link library, then it will happen at launch time. The operating system finds all of the DLLs that your program requires, and it loads them into memory so that you can actually call into them. Your program needs to delegate execution into the code in these libraries, so they need to be in memory. So with DLLs, the creator of the library builds a binary package that is the DLL file, and that needs to be distributed to the people who use it, us programmers. You also have to distribute the header file to go along with it, so that you can include it and your code knows what functions are available. And you usually have to have a sort of import library. So in Visual Studio, that's a .lib file. In like GCC, it's a .a file. And so you link to that file so that your linker knows what functions are available in the DLL. So then you have to distribute that DLL along with your program. You build your program, you build your, you link to the library, and so you have two separate binary files that need to be shipped together so that it can link at launch time. There is a way to load a library dynamically during the runtime of a program, but that's a little more rare. So I want to show you an example of that one. This is a library I commonly use, SDL. And SDL has, you can find its binary distribution. This is one that's a little bit older. But you can find in here the include files. Normally you just include SDL.h and it includes everything else that you need. But there are some special ones in here that you might include separately. So you need the header, and then in lib, let's look at the x86, the 32-bit version. You'll find the DLL, that's important, and a .lib file. So that's the import library that you link to in Visual Studio. There's also an SDL2 main.lib, so another lib file that's just kind of helpful for some cross-platform differences. Windows has a special main requirement for graphic programs, so that's why this exists. But generally you have a lib file, you have a DLL, and you have a .h or a header file. And those are all the things that someone needs in order to use your library. And then there is a last form of code library, another way to distribute your code, and that is as a static library. A static library is just like a DLL library, except without the DLL. So it still has a header, still has a lib file, but instead of linking dynamically at runtime, this links statically at build time. So all of the functions that your program actually uses are linked into your program and become part of the binary program that you create. So you don't need to distribute any second part of your library. Now this has advantages because you're only linking the stuff that you need, right? So you don't need to distribute all of those extra functions bundled in the DLL that you're not even using. This can slim down your binary, make it smaller. There's also no DLL boundary crossing where you have to call into that code, so it may be a little bit faster, but very slightly. And it has to trade off though, because when you link statically, if you need to make updates to the library, if you update the library to a newer version to fix some bugs or something, you'll have to recompile your entire program and send that back out to all of your users. With a DLL, you just have to ship the extra DLL. Maybe your automatic patching program or whatever, your update program is just going to have them download the new DLL. Replace the old DLL and it just magically works because it gets linked at runtime. So those are some of the trade-offs there with static libraries, and you have to decide which one of these options makes the most sense for your code to be distributed, or if you're using a library, which one of these methods does it use and how should you be linking to it. Alright, so that's how, those are the options for how libraries are distributed, how they're linked and used, and I hope you understand that a little bit better now. See you later.